afternoon all. We'll wait for everybody to join and we'll start it in a minute or so. Good, we'll give it a couple of more seconds and we'll go ahead. Good, I can see quite a few people joined already. So thanks everybody for joining us this afternoon. And this time we'll be talking about hydrogen peroxide wafer decontamination cycle validation using electronic indicators. And just to go through what's coming up. So we'll discuss hydrogen peroxide mode of action. We'll talk about decontamination cycle parameters. We'll talk about cycle validation using biological, chemical, and enzymatic indicators. And we'll talk about cycle electronic indicators. At the end of the session, we'll hold a Q&A section. So please use the Q&A tab to post any of the questions throughout the webinar. And we hope to answer as many questions as we can. So I'm delighted to say that this time I'm joined by Enrico Allegra. He's our lead microbiologist.
Hi, everybody.
And Kurt Morgan, he's the embedded system engineer. Good. So with that in mind, I'd like to hand over to Enrico to talk about hydrogen peroxide technology. Go ahead, Enrico.
Right. Thank you very much, Tautvydas. So first of all, I'm very delighted to be here today. I guess a good place to start will be to talk about what is hydrogen peroxide vapor technology. So we know that hydrogen peroxide vapor, it's a relatively rapid biodecontamination technology, and it's mostly produced by vaporization of liquid hydrogen peroxide, which will give a mixture of hydrogen peroxide vapor and water vapor. We know that he has a broad spectrum antimicrobial activity, and in fact, it's been proven to be virucidal, bactericidal, fungicidal, sporicidal. Amongst all of these, we know specific organisms such as MRSA, Clostridium difficile, E. coli, and many viruses such as flu viruses, influenza, retroviruses, and also some coronaviruses. They all been proved to be susceptible to hydrogen peroxide. We do know that in the decontamination, it helps reduce the bacterial load from up to 6 log, and that's why we can't technically use the word sterilization, but that's why we call it a biodecontamination, as we won't be able to deplete everything, but all the surfaces will be very safe and reduce the risk to personnel entering that room, for example. So talking about entering a room, so it is at the moment HPV is currently used for decontamination of different industries with different applications. Very important in this case are the healthcare settings such as hospitals, care homes, and laboratories. We know that thanks to the obviously very small molecules of hydrogen peroxide, the HPV is able to reach all exposed surfaces, is able to enter tiny cavities, and is also able to readily pass through HEPA filters. Hence why such a, it's becoming more and more a very important tools for keeping infection down. We know that it has various mode of action. We know from literature there are 3 main mode of action. The hydrogen peroxide interacts with a microorganism. So the first one and the most recognized is through interaction with DNA or the genetic components of microorganism. So we know the hydrogen peroxide is able to cause breaks into DNA strands, and there's been studies showing that individual strands of DNA will be detectable after exposure to hydrogen peroxide. These obviously will lead to the cell death of obviously bacteria and viruses. And this is one way which has been proved and shown of sort of the mode of action of hydrogen peroxide. A second and also very widely thought is the oxidizing properties of hydrogen peroxide. So we know that hydrogen peroxide it's a strong oxidizing agent and is capable of oxidizing many proteins and lipids found on bacteria. Due to the oxidization, it will lead, obviously, will remove electrons from these molecules, and therefore will render them obviously not capable of functioning, and will eventually lead to cell lysis and cell death of bacteria. And another very interesting mode of action, which has been sort of studied, especially on bacteria, is the interaction with ion molecules. So we know ion molecules are used within bacteria for reproduction, respiration, and many other processes within the cells. So their presence is being shown to help hydrogen peroxide in achieving death. In fact, we realize through various studies that the chemical interaction of hydrogen peroxide with ion molecules will actually create highly toxic hydroxyl radical. So this hydroxyl radical will be released into the environment and therefore will create holes into bacterial cells, causing cell death. Also, worth mentioning that the hydrogen peroxide is readily sort of decomposed into oxygen and water, making it a very safe or a much safer option to many of the let's say competition out there, such as formaldehyde or ethylene oxide, and therefore it also requires let's say a smaller sort of exposure times compared to these other used decontaminating agents, making it also a better choice, hence why it's become more and more used, especially nowadays during our pandemic. So if we now move on to my next slide, we can talk about actual efficacy. So I've discussed about what is hydrogen peroxide, where it's commonly used, and how it interacts with the microorganism. Now we know there has been proven to be effective, and the efficacy is mostly related to various factors. So also we know the mode of action, but how we actually, how is the actual efficacy obtained? So well, from this study we can see. So this is a nice study being performed on influenza virus H1N1, and the graph will show you different concentration of hydrogen peroxide and the difference also in the correlation of log reduction against time. And we can see that, for example, the concentration of 57 ppm after 15 minutes exposure time has reached to 3.5 log reduction, where a 90% ppm concentration has reached much higher a reduction, almost a whole log reduction. And we wonder how come there's such a huge difference between such a small variation in concentration. And most likely what we think is condensation is happening. So if we think about the way hydrogen peroxide is being delivered into the room, it will be injected into its gas or at least a vapor phase. The vapor will eventually reach a threshold, which will then turn from vapor into condensation. So this condensation will probably deposit on surfaces, and that's what we think is actually causing the actual, so it's contributing to the death of organism. My next slide will actually now sort of talk even more in depth about this concept. So this graph is showing, again, a correlation between hydrogen peroxide concentration, temperature, and the condensation point. So if we, for example, trying to correlate to the previous graph, we'll look at the sort of around the 80 ppm, sort of 79 in this case, at 20 degrees, that's when the condensation is starting to happen. So taking into account this information, we can now understand how come between sort of the 57 and the 90 ppm, for example, there was such a big gap. Most likely what we think is, in fact, is happening is that after that threshold is reached, a lot more condensation will happen, and therefore a lot more hydrogen peroxide will be deposited on the surfaces, causing death. So we introduce various factors at this point. We introduce temperature parameters, temperature, humidity. We introduce concentration of hydrogen peroxide. So there's a lot of parameters up there that probably will need to be monitored by the technology delivering these, capable, therefore, to then correlate the successful of the cycle with the reduction. And in fact, from we can say that we know the cycle parameters probably play a very key role in terms of the efficacy. And to talk about that, my colleagues now will share more light. Therefore, I'll leave now the words to Tautvydas.
Thanks, Enrico. No, I think it's really important to understand the exact mode of action that we achieve efficacy using hydrogen peroxide. And it's really good to see that you might start with one phase of hydrogen peroxide, but ultimately end up with a different phase actually doing the killing. So this is what I wanted to touch on, is that different technologies are actually being used to deliver hydrogen peroxide decontamination cycles. And with that, there's different parameters that they monitor. And it's important to say that you have systems that monitor nothing. So they would just inject a dose of hydrogen peroxide and would expect to get the right level of efficacy. And on the other side, there's systems that do monitor specific cycle parameters to try and get efficacy every single time. The ability to monitor various decontamination cycle parameters significantly enhances effective cycle development. So if you monitor cycle parameters such as temperature, humidity, process time, hydrogen peroxide concentration, you can actively see what should be the best cycle parameters to achieve the right level of efficacy. And you can scale that to specific circumstances or the challenge in whatever environment you're dealing with. But we know that hydrogen peroxide concentration and relative humidity are the most widely monitored during the decontamination cycles. And rightly so, from the graph that just Enrico showed, it seems that if you're monitoring hydrogen peroxide concentration, you're likely to establish at what point you'd achieve your condensation. And at the same time, if you monitor relative humidity, you can also predict and estimate when the condensation would occur, giving you the right level of efficacy. Well, I suppose the main aim is to define your decontamination cycle using those cycle parameters in order to reproduce the same outcome, so the same efficacy each time you deploy the process. So some of the key challenges that we see with cycle development is that how do decontamination systems report successful process completion, and what does it mean to the operator? So suppose if we look into any of the various different technologies and systems available, what does it mean when they say that the process is complete? Is it that the process was complete because we've injected just the right amount of hydrogen peroxide, or is it that we are able to match the cycle parameters set to make sure we get the right level of efficacy? The other challenge is that how do manufacturers establish that link between the efficacy results and reported cycle parameters? How do we make sure that everything we've done in our test phases and process validation, we actually achieve the same cycle parameters during the actual processes? We know that traditional validation methods either take a long time or only validate a single process parameter, which in turn questions its reliability. So there's various validation methods using biological indicators, chemical indicators, or enzymatic ones, but we know there's specific issues with some of them. And finally, is how do healthcare facilities maintain their audit trail using their audit trail of their decontamination program? If we're using different ways of validating cycle effectiveness, how do we collect all of that information in a single place to make sure we can look back on it? So we know that cycles are traditionally validated using chemical indicators, or could be validated using chemical indicators. And chemical indicators basically work on a simple reaction of paper strip reacting with the presence of chemical. It's fair to say that chemical indicators monitor a single cycle parameter, which is the presence of chemical, and they can't actually monitor the efficacy. So the attempt being made to try and calibrate chemical indicators against the efficacy, but it wouldn't necessarily give you the full view of what cycle parameters have been met during the process. So hydrogen peroxide technologies have variable cycle parameters, and these chemical indicators only control or only respond to a single cycle parameter. And there's some limited evidence to support that chemical indicators can be effective at measuring the efficacy of the process. So I think chemical indicators do have a role to play as a useful supplementary measure to show the presence of chemical and whether the chemical was able to penetrate into occluded areas. On the other hand, we have biological indicators, which is considered to be the gold standard of decontamination cycle parameter validation. And it's done by monitoring a number of survived microorganisms. In fact, we can actually choose to use most resistant organisms like Geobacillus thermophilus, which is the most used in hydrogen peroxide process validation. And the reason why it's a gold standard, because ultimately you do get the result to make sure that the sample you've just delivered had returned the right level of efficacy. However, it does require 7 days to provide the results. So that's the incubation period, and it renders the process impractical in the actual scenario where you're trying to decontaminate side room, for example. So biological indicators is a very good tool to develop your decontamination cycles to get the right level of efficacy. However, there's some difficulty with using those on your normal processes. And similar to CIs, they cannot really determine what your cycle parameters. They only show whether you've achieved the right level of efficacy. Similar situation with enzymatic indicators, apologies for that. They mostly use enzymes isolated from thermophilic bacteria, and it represents a protein that's very difficult to remove from surfaces. So then it catalyzes a reaction that produces light, and that light is measured to show what sort of effectiveness the hydrogen peroxide cycle could achieve. So it's a good attempt to try and get all the benefits of biological indicator and get the speed of response from chemical indicator. However, we still know that there's limited literature to support its efficacy, and the whole process is dependent on one enzyme. And with that in mind, I'd like to hand over to Kurt to talk about the electronic indicators.
So, thanks, Tautvydas. Electronic indicators is a term that we're starting to use in the industry to describe the best practice control of HPV systems, as Tautvydas was describing earlier. Electronic indicators use continuous readings from a collection of electronic sensors to validate that a cycle was effective. Chemical indicators change colour based on exposure to one chemical, so they don't measure the efficacy at killing organisms. Sterilisation systems, where chemical indicators come from, have a very controlled cycle. Either the equipment works or the equipment's broken and it doesn't. So chemical indicators are very appropriate. And under normal conditions, the chemical indicator would show that either the sterilizer has worked or it's not. Whole room decontamination systems aren't the same. Temperatures, humidities, room sizes, surfaces, they all vary. And varied cycle conditions can and do occur, and decontamination cycles could be more or less effective. A range of colour changing conditions could occur, but chemical indicators are only tested to work on one particular cycle with very specific parameters. So modern HPV decontamination systems have electronic indicators. They measure the key cycle parameters, the relative saturation, ppms, humidity, temperature, over time. Systems react to conditions to maintain these cycle parameters, and the electronic indicators show that the required conditions for efficacy were met for the required time. To be clear, the electronic indicators, well, they can't measure efficacy at killing organisms either, but they can show that the conditions from controlled trials with biological indicators were met very precisely. So on the next slide, modern HPV systems, they measure the temperature, they measure humidity, they measure ejection rates of the hydrogen peroxide and airflow over the course of the process. Modern systems attempt, as Enrico was explaining earlier, to inject hydrogen peroxide until a fixed threshold is met, and then to maintain that level for a fixed dwell time. This threshold and dwell time are set to match trials with biological indicators, the gold standard. The system validates when the cycle completes and that the process matches the process from controlled trials, and then gives a green thumbs up in our case. If conditions can't be matched in controlled trials, so if the room is too hot or too humid or there wasn't enough airflow, the operator can be told that immediately before starting the process, because they might actually be able to address this by opening some windows or making sure that the machine's been serviced. Also, if during a cycle the system can't actually maintain the control conditions in the room, it can deactivate as soon as it can detect that, and then get the room back to some safe entry conditions so that the operator again can see what's happened and perhaps fix this and ensure successful processes as many times as possible. On my final slide, the systems all send processor, well, in fact, Inivos systems send processor readings back to a central server. This independently checks that the results are correct and that cycle parameters have been met, and emails a report to validate the process is correct, which is useful for maintaining an audit trail. Technicians can also monitor system behavior, so they can notice wear to machines and patterns of operation. This allows systems to be maintained proactively before any problems actually occur in practice. It's also possible to notice issues to do with cycles in particular areas, which allows technicians to talk to the operators concerned to try and make sure that they get successful processes in those areas. It's important to say, though, that we are relying on electronic sensors and software to make this work. So we need to make sure that that software and those indicators are being made reliably, and that their maintenance and use is as controlled as you'd expect for chemical or biological indicators. It's important that we apply best practice in software development and the best engineering practice in calibration and maintaining of the sensors. The other point is that trials are normally conducted to show that cycles are successful. We need to acknowledge that it is complicated and that conditions vary, and we need to investigate the mechanism for success and for failure to understand the full range of success and failure criteria and thresholds. The electronic indicator is a collection of sensor results and reading thresholds. They both have to be right for the indicator to be effective. So back to Tautvydas, hopefully.
Thanks, Tut. No, I think it's really important. And I think it's really important to say that, we've been developing decontamination cycles, for quite a while now. And one way we saw for us to be able to improve is to actually understand exactly what happens throughout the decontamination cycle in order for us to try and see which sort of parameters need to vary or change in order to get the right level of efficacy. At the same time, reducing the process time and reducing the concentration of our starting solution for hydrogen peroxide. And I suppose what we thought is that because we use these cycles essentially to lock in these cycle parameters and then run the process to validate that with biological indicators, well, the obvious idea is that we should use these electronic indicators as equally as a chemical indicator to show that the cycle is successful. And I suppose combined with the whole IoT Internet of Things idea is that you do get that software report at the end of the process to show if the cycle had been successful, alongside all of the other parameters to show that the system was working and whether everything was done in accordance with the standard operating procedure. So in the past couple of years, I really enjoyed working with Kurt to try and find ways of what do we need to do, what do we need to measure, what sort of sensor arrays we need to put in place in order to develop the cycle to make sure we can save time and present the results. So I'd like to go into the Q&A section to see if anybody had any questions. Meanwhile, Kurt, would you like to talk more about the Internet of Things and how that works with the whole validation of the cycle parameters in the cloud?
Yes, but so it's the Inivos peroxide machines and ultra-low machines also report all of the parameters from their cleaning cycles over a 3G internet connection at the end of every cycle. So our technicians are able to watch them. We have regional hubs where our technicians are responsible for a particular set of machines, and they actually pay careful attention to what's going on day by day to see which machines are being used, and they're alerted immediately if any cycles have failed. So the technicians actually go and look at the detail of the sensor readings to try and figure out what's going on, and many times they've actually been able to phone up the individual operators and find out what's going on and help them to make sure that processes are completed every time. And if they're not able to do that straight away, they can often figure out what might be wrong with the machine and then make sure that they can go and service it with the correct parts straight away.
Okay, and I think it's important to note, I think from Enrico's point of view as well, is that I suppose as soon as you get that validation report, what we essentially mean by that is that we were able to complete the cycle that we validated. So we were able to meet all the target parameters that we have done when we did the cycle validation with active live biological indicators. And if we cannot reproduce the same cycle conditions and parameters, we would fail the process. So there's no ambiguity about the success of what actually happened.
No, there isn't, and we do actually fail processes. I think that's a bit of a differentiating factor between our approach and some other people's.
Okay.
We notice the starting conditions for doing a cycle in a room, and we notice how the cycle is progressing. And if we deviate from what we know is effective, then we immediately stop the process and tell the operator and try and give them a chance to fix it, because we promised a certain level of efficacy in the manual, and that's what we're attempting to deliver.
And we actually just got a very, very interesting question, potentially from one of the users of our systems. They say that why does humidity have such a great effect, as they're saying that most of their fails are to do with humidity. And if I can start answering that, and I'll probably ask you to comment. So I guess this is exactly our point. So our systems do measure the starting conditions to make sure that before we even attempt to do the process, the conditions are right. And that's the whole beauty of us having confirmed the cycle parameters that were to be effective. So I suppose there's two options there. Either the humidity is just simply too high, which basically means that we cannot inject the right amount of chemical because it will just simply condense and we wouldn't be able to reproduce the same cycle which we did at validation point. And the second option is that if we weren't able to reach the target parameters, which means that we weren't able to increase humidity in our process, we would say that the process is unsuccessful. Kurt, would you like to comment on that?
Yeah, I think that's a very fair comment. I suppose it must be a bit frustrating if you're trying to use a piece of equipment and it says it's not working. But again, we're trying to measure the conditions to make sure the cycle's effective. And it's better to be upfront about that and say it straight away. It gives people a chance to respond. I suppose in terms of people operating our systems, that some of the problems that we have are to do with temperature in rooms. If it's very hot, it really does take a lot more hydrogen peroxide to reach our thresholds that we're expecting than if it's cold, for example. So that, there are certain times of year when it starts to become an issue, and we all notice that. But when we get a green thumbs up with our electronic indicators, it means that the cycle's been effective, and we can be sure that the efficacy levels have been met.
Yeah, and I think this is the biggest difference with if you look at technologies or systems that measure nothing. So I suppose if you just run a process without understanding what you're trying to achieve, you're unlikely to you're likely to fail and not achieve the right level of efficacy.
Yeah.
There's a question here. It says you mentioned that the system would stop the process if it couldn't maintain the achieved parameters. Sorry, this could be seen as a negative, but does it mean that the system will not run the process unless it be completely sure it's killing all the pathogens? I think it's a continuation of what we just said, but you want to comment on that?
I think it is a bit of a continuation. We do actually try to notice up front if we're not going to be able to start a process. So in terms of not running a process, hopefully systems might be able to show operators straight away if the conditions aren't to be met, if the machine needs to be filled up or room's actually too hot. The machine should be saying that up front, if it's all possible, so give people a chance to respond, because the cycles do take a while. HPV technology is great. As Enrico was saying, those molecules are really small, they penetrate all the spaces. We have Ultra-V technology for when we need to do something quickly, but when we need to do it well, we use HPV technology.
Good. I think there's a follow-on question to say that people understand what impact humidity has, but why does the systems allow for the different levels of humidity? Do you want to comment on that, Kurt? And then perhaps...
Unfortunately, humidity kind of has some fixed levels. You can't go more than 100%. If you go more than 100% humidity, then we get rain inside a room, and that rain is not hydrogen peroxide; it would be water, and it'd be reducing the concentration of solutions on the surfaces, and that would make making the process less effective. So we are a little constrained, and in the UK we have starting humidity of normally 50% because that's what the air is like in a room. So we certainly account for things as far as is possible. And we try to meet those controlled cycle conditions to make sure that we've shown that they're effective.
Yeah. And I think just following on that, I think Enrico had mentioned about the two different mode of actions and whether we try and get the efficacy using gaseous phase or condensation, which is likely that most processes do end up condensing on the surface. Well, once we know the right amount of hydrogen peroxide you need to achieve the right level of efficacy, well, once it's done the killing, well, then you go over to the activation phase. So in essence, the less hydrogen peroxide you have to deal with after, the better. So in a way, we were trying to develop the cycle that has the shortest process time, and there was quite a few questions how long the process can take, and it can be as little as an hour and 45 minutes, and obviously depending on the size of the room, that could be longer. But we established that all phases, injection, dwell, and deactivation, do play a vital role. So we're trying to use just the right amount of hydrogen peroxide to achieve the right level of efficacy, and no more, so that the deactivation phase would be significantly shorter. There was a question there that talks about how does the absorbency of the surfaces affect the decontamination cycle? Kurt, would you like to comment on that? And perhaps Enrico can comment on the mode of action and the efficacy of the cycle.
In terms of process times, our machine's trying to reach the certain humidity thresholds it's operating. So if surfaces are absorbing the solution that's been injected, it takes a little longer to inject. But we obviously continue injecting until the thresholds are met. And during the cycle, if a room has got lots of absorbent surfaces, the machine may have to re-inject several times to make sure that for the entire dwell period, the thresholds that were tested against the gold standard biological indicators are actually met. So I don't know, Enrico, if you have anything to add to it.
Yeah, no, I guess that's fair. I mean, the absorbency of materials will also impact, perhaps in fact, sort of trying to maintain that constant humidity, that constant threshold. Obviously, with the more absorbent material, may be more difficult. But that's why the system will be able to monitor it in a way constantly, what's sort of in a way happening in the room, especially in terms of the main parameters that we're looking at. And by maintaining that sort of, throughout the system, even though you might have loads of absorbent material, your cycle might just be longer, but the system will be able in a way to compensate for that, and therefore you'll still be able to achieve the right efficacy. And I guess in a way, from especially my point of view, the most important thing is be sure that at the end of your cycle, you can definitely say we actually decontaminated the room, because it's not just having a green thumbs up from your system. I guess it's good enough. You need to be able that green thumbs up need to be reassuring that it also means yes, you have actually killed, you have reached that log 6 reduction. And I guess that's why it's so important to validate these parameters, because once you have all these parameters being validated, then again, the size of the room, the contents of the room may just make the cycle slightly longer, but it will not affect its efficacy, if that makes sense.
Yeah.
We just got a very interesting question which I definitely would like to ask, is that when we say condensation, are the surfaces wet? And I'd like to take that one, and then obviously we'll discuss it. So it's a very good question. And this is where we spend most of our time developing these cycles. So we understand hydrogen peroxide really well, and we know what we're trying to achieve with it. And we know we can get hydrogen peroxide condensing in certain levels. And although we're technically speaking, the surfaces do get with hydrogen peroxide, but we control that condensation to make sure that at the end of the process, surfaces are completely dry. So when we speak about measuring hydrogen peroxide concentration or hydrogen peroxide or humidity in the room, we can stop injection at certain times to make sure you get a very, very fine layer of hydrogen peroxide condensing on the surfacing, achieving superior efficacy without making all the surfaces wet in a traditional sense of you see all the surfaces wet. And when you come back after the deactivation phase, all the surfaces are dry, and you're left with, well, humidity in the air, because hydrogen peroxide does break down into oxygen and water. Do you want to comment on that, Kurt? I think that's a very good question.
I think by analogy, if I have a bath, I'm definitely wet. But when I get out and towel myself down, I am dry. I'm certain if I sat in a desiccator for a little while, I might get a little drier. But for functional purposes, I'm dry. And likewise, when we run a cycle, the process is dry in the sense that it doesn't leave any surfaces damp afterwards. And things like equipment are perfectly safe inside the process environment, even if they're not rated for sort of wet conditions. So you can use a HPV decontamination system pretty much anywhere and expect not to damage any equipment that's in the room or any of the surfaces in the room. I think that's fair to say, Tautvydas. And
then, and one for you, Kurt, as well. There's a question about if we're using electronic indicators and if we override those machines, can we get how do we indicate the right level of efficacy? So I suppose the question is it possible for us to go and override the machine and trick the machine into thinking that there's certain cycle parameters and
not really. I mean, even if I've developed some of the software for this machine, so I can certainly fiddle around under the hood and make them turn on and off when I want to. But the server actually validates all of the actual sensor readings. So at the end of the day, I can't do anything that wouldn't be correctly validated in the end. The server will check the readings. If I were to say, I think perhaps this is a comment more about how the machines are controlled in general. Obviously, we monitor the results from all the cleaning cycles that go on, and we do our best to improve and improve. And that's something we're actually doing. Our peroxide machines are able to have more and more fluid now to run for longer and longer. And we're optimizing our process cycles to make sure that there are fewer and fewer processes that do actually fail. So that's something that we're very interested in. I mean, we certainly are concerned whenever an operator is using a piece of equipment, it doesn't just work, because we want this to work every time. And we are doing our very best to make sure that where it's physically possible, the machine will actually continue the cycle. You don't need to think about overriding it. The machine is actively trying its best to maintain the cycle conditions and to get you that green thumbs up.
So I suppose, just to try and summarize, I think so what's the future of hydrogen peroxide decontamination cycle development? I personally think we have a very good biological indicator to try and get the gold standard to make sure that our decontamination cycles are effective and that we can reduce the risk of cross-infection. Now, clearly, there's attempts made to use specific cycle indicators like chemical indicators or enzymatic indicators, etc. I think we as cycle developers and technology developers are trying to find ways of how do we get you the result that you can rely on straight away without implying that you have to wait, because we know the pace of healthcare. So I suppose I believe that the future is that if we develop cycles using these electronic indicators to make sure we do get the right cycle to get the right level of efficacy, we should use the same electronic indicators to validate our cycle, and which provides, from my point of view, more reliability than chemical indicators that only monitor single cycle parameters. So the future is that once we get on top of understanding exactly what decontamination cycle parameters require, we can go and improve to try and further reduce the concentration of our starting solution, making it safer for the operator and achieving the same high level of efficacy, and then combining that knowledge to develop the shortest process time. Because again, as I mentioned, as soon as you get the right level of efficacy, well, then you have hydrogen peroxide to deal with. At the end, you need to deactivate, and that's the next phase where we're hoping to invest more time and knowledge to see how can we even shorten the process time, knowing those cycle parameters. So Kurt, final word from you.
I suppose this is where I see all modern HPV systems going. I think electronic indicators is the way. It gives you the best chance of telling, given the limited information you've got, that the cycle was effective in the minimum timescale. You get almost the same indication surety level that you might have with a biological indicator, but you get it immediately. And I think that that's surely where the industry is going to be going.
And then, Enrico, just from your point of view, I suppose if we're able to control our decontamination cycle parameters precisely, I suppose from a microbiology point of view, we can run these validation trials to see what sort of level of efficacy we can achieve. So in a way, it enables us not just to use biological indicators as just a final means of saying, yes, we're effective. I think it definitely enables us to try and see how can we change the cycle to maintain the effectiveness and make it safer and more sustainable going forward.
Yeah, no, absolutely. I mean, I think the key word here is validation. Trials, validation, and that will eventually, give you that ultimate confidence that once you run your cycle, you actually achieve the killing. Because I think I just wanted to point out that obviously we do know that the thumbs up is not actually telling you, yes, everything is dead, you've actually killed. Thumbs up is only telling you we achieve all the parameters that we set. We achieve every single parameters. So I see why people would still go back to BI, sort of biological indicators, as the golden standards. But then my argument would be, if you're able to prove through a series of validations that your system is constantly delivering, if you reach those parameters, is then delivering death of the microorganism, i.e. you're achieving that efficacy that you're looking for, then therefore you're validating your system. I just want to point out that I heard, and it kind of made me think, and I really think it's not possible. I heard that some people try to validate chemical indicators, which, as you mentioned before, is just a 1 point kind of parameters, which is incredibly difficult to sort of correlate with efficacy of killing microorganisms. And that's why, my final thoughts is, yes, if you're able with your system, with your electronic indicators, to achieve all the parameters that you set, and those parameters are then, basically they equal death of organism because you've tried it and you validated your system, and then yes, the future will be electronic indicators. And I guess at that point, you can remove the BI and the need of waiting 7 days before you can re-enter the room. So yes, absolutely.
Excellent. Well, thanks both. Really enjoy this, and I can't wait to talk to you in the next one. Thanks everybody for listening.
Thank you all.
Goodbye. Thank you.
Thank you. Bye-bye.